In this lesson, we'll learn about stack and queues. These are two of the most important data structures you'll come across in computer science and coding interviews. In this lesson, we'll learn the meaning of stack and queues, how they work, and how you can build them step by step using Python. By the end of this lesson, you understand the core ideas behind stacks and queues. You'll see how to apply them in real-life scenarios and how you can implement them in your programs. So let's begin with the stack. When we talk about stack or stacks, we're talking about a linear data structure that follows the last in, first out principle, otherwise known as LIFO principle. This is a situation whereby the first item that you put in the stack turns out to be the last item you bring out. Just imagine stack of books or stack of plates, or let's paint this scenario. You want to stack books on a table, on an empty table. You start with the first one, you place it on the table, you bring the next book, place it on top of the first book on the table, you continue that way. And when you want to remove items from a stack, you start from the top. So this is what we call the last in, first out principle. And now we're going to be implementing the stack data structure in Python. But before we go ahead with the implementation, let's see some of the key operations we can perform on stacks. So the first one is push operation. With push operation, you can be able to add items on top of the stack. We'll have the pop operation that allows us to remove items from the top of the stack. We'll have pick. Pick allows us to see the content of the last item on the stack without removing it. We'll have is empty, which allows us to check whether our stack is empty. And finally, we'll have the size, which allows us to determine the number of items in our stack. So let's go ahead and implement this data structure using Python. And we'll start by creating the stack class. So I have class stack. Then we go ahead and create our constructor. So we have def init, and we'll have self. Then I put a colon. Then I'm going to be initializing an empty stack. So I have self.items is equal to, I'm using an empty list. With this, we're done with the constructor. So let's go ahead and implement some of the key operations of stack. And we're going to be starting with the push operation. The push operation allows us to put item on top of a stack. So I have def push. We'll have self, and we have the item that we want to push into the stack. And for this, we're going to have self.items.append. I'm using the append method of the list. Then I provide the data or the item that I want to stack on top of the stack. So we have item here. And with this, we can be able to perform the push operation. Now let's go ahead with the pop operation. The pop operation allows us to remove the last item on a stack. So we have def pop, and we have self, we have colon. But before we go ahead with the pop operation, we need to be sure that the stack is not empty. And to do this, we have if len, then we have self.items is greater than 0, which means it is not an empty stack. Then we'll go ahead and return the last item on the stack. So we'll have return self.items.pop. This is going to return the last item or the item on the top of the stack. But in a situation whereby it is an empty stack, then we're going to raise an index error. So we'll have raise index error. Then for the message, we'll write empty stack. Then close this. Now let's go ahead and implement the pick operation. With the pick operation, we can be able to see the content of the last item on a stack. So we'll have DEF pick. We'll have self here. And to perform this operation, we need to determine whether the stack is empty. And if the stack is empty, we'll raise an index error. If it is not empty, we'll go ahead and display the content of the last item on the stack. And for this, we have if len self.items is greater than 0. Then we'll return the last item on the stack. And this is return self.items. Then we use -1 to return the last item in the list, which is this. I close the square bracket. But if not, we're going to raise an index error. So we'll have raise index error. And for the message, we'll still use empty stack. Then the next operation we'll look at is determining whether a stack is empty. So have DEF is empty. And we have self. And to check whether it's empty, we use the len method. If it is greater than 0, the length of the stack is greater than 0, it means it is not empty. So we'll have return len self.items equal to 0. If the length is 0, it is going to return true. But if the length is greater than 0, if it is not empty, we're going to get false. Then finally, we'll implement the method for determining the size of the stack. And for this, we have DEF size. So have self here. And all we need to do is to return the length of the stack. So we have return len self.items. And that is all. But before we conclude, we're going to be implementing a method that displays the content of our stack. And for this, we have DEF display. This is going to display or return the content of our stack. So have self here, and this is going to return self.items. And that will be all. So let's go ahead and implement this stack. So I'm going to be creating an object of this stack. So we have stack is equal to stack. And I'm going to be pushing an item into this stack. So I have stack.push. And I'm going to put one there and go ahead and print the content of the stack. So have print stack.display and run the program. So you can see we have 1. So let's push other items. So I'm going to copy this, paste and paste. And this is going to be 2, and this is going to be 3. And let's run it. And we have 1, 2, and 3. So let's go ahead and pop an item or remove an item from the top of the stack. And for this, we have result is equal to stack.pop. And we'll print the result. But before we print the results, we need to see the content of our stack before the pop operation. So I'm going to copy this and paste it below and run it. So you can see we've removed 3, and 3 happens to be the element at the top. So push is used for stacking things on top of our stack, while pop is used to remove items from our stack. Now let's determine whether our stack is empty. And to do that, I'm going to have print stack.is empty. Then run it. You can see it is false, which means that it is not empty. But let's try this out before pushing items into our stack. So I'm going to copy this and paste it immediately after I created an object of the stack. Then run the program. You can see it is true here because it is empty at this point, but at this point it is not empty. Now let's see the size of our stack. And to do this, we have print stack dot size. Then run it, and currently the number of items in our stack is 2. So this is the basic implementation of the stack data structure in Python. Next, we're going to be looking at the queues. A queue is a linear data structure that follows the first in, first out principle. Just imagine a queue of people in front of a supermarket, or a queue of people in front of customer service, or even queue of vehicles in a traffic. The first to get into the queue is the first to get out. And this is what we call first in, first out principle. The first element added is the first one to be removed. And queues are very important data structures in programming. We use queues for task scheduling, for printer queue management, for customer services queues, and so on. And now we're going to be implementing the queue data structure using Python. But before we do this, let's look at the 4 types of queues you may come across in programming. We have the simple queue, we'll have deck, we'll have the circular queue, we have the priority queue. So we're going to be starting from the simple queue. The simple queue is the simplest and the basic implementation of the queue. And just like our definition, queues operate in the first in, first out principle. But before we go ahead with the implementation of the simple queue, let's look at some of the operations we can perform on a simple queue. We'll have the enqueue operation. Enqueue means adding item to the rear of the queue, which means at the back of the queue. We'll have the dequeue operation. Dequeue means removing items in the front. We'll have front views. If you want to see what's in the front without removing it, you perform a front operation. We'll have is empty. Is empty is to check whether the queue is empty. And finally, we have the size, which helps us determine the number of elements or number of items in the queue. So let's go ahead and implement the queue class. So we'll start by defining our queue class. So we'll have class queue. And we have our constructor, which is init. And we're going to initialize an empty queue. So we'll have self.items is equal to empty list. Now, let's go ahead and implement the queue operations or queue methods. And for this, we're going to be starting with the enqueue operation, which allows us to add items at the rear of the queue. So we'll have def enqueue. And we have self, and we have the item that we want to enqueue. For this operation, we're going to be using the append method. So we'll have self.items.append, then we'll have item. So we have def the queue, and we have self here. But before we dequeue, we need to check whether it is empty, whether our queue is empty. If our queue is empty, we're going to be raising index error. So I'm going to have if len self.items is greater than 0, then I'm going to be popping. I'm going to be using the pop method of the list to remove and return the first item in the queue. And I'm going to be providing the index while using this pop method. So I'm going to have return self.items.pop. then I specify the index, which is 0. That is the first item in the queue. But if we're dealing with an empty queue, we're going to raise index error. And I'm going to write empty queue. And that will be all. Then the next method we're going to implement is the method that determines whether our queue is empty. So we'll have def is empty, and we'll have self, and I'm going to be returning true or false depending on whether the length is equal to 0. So I'm going to write return len self.items equal to 0. If it is equal to 0, it means true. But if it is not equal to 0, it means it is not empty. And that will be all. Then we'll look at the method to determine the number of elements in the queue. And we'll have def size. And we'll have self here. And we're going to be returning the length of the queue. So we'll have return len self.items, and that is for the size. Now let's display the content of our queue. To do that, I'm going to have def display, and I'll simply return self.items. So let's go ahead and try this out, and we'll start with queue is equal to queue. And I'm going to perform an enqueue operation. So we'll have queue dot enqueue. And we'll have 1. So let's go ahead and print our queue. So we have print queue dot display. Then we'll run it. You can see we have 1. So let's add more items to our queue. So I'm going to change this one to 2, and this one I'm going to change it to 3 and run it. So we'll have 1, 2, and 3. So this is basically our queue. If you look at the output, you can see we have 1, 2, and 3 in form of a list. There is no indication that 1 came before 2 and 2 is before 3. So we're going to be modifying our display method to perform a sort of traversal and put an arrow to indicate that 1 is ahead of 2 and 2 is ahead of 3. And to do this, we're going to have 4. Item in self.items. And here we're going to have our print statement. So have print. Here we're going to have item, and we have an arrow pointing to the left. So have this. Then we have our end argument, and we have just a space. We'll close the parenthesis. So I'm going to go ahead and remove this return, and I'm going to be removing this print statement here since I have print inside of the display method. Then go ahead and run the program so you can see it is looking like a queue. Now let's perform a dequeue operation. Dequeue operation is used to remove the first item in the queue. Currently we have 1 at the beginning, so we're going to have item is equal to queue dot the queue. So let's print the item that is removed. So we'll have print item. Then we'll run the program. So 1 was removed, and now you can see that 2 is now in front of the queue, followed by 3. So let's perform another enqueue operation. So after this, I'm going to have 4. Then we'll run it. You can see it is working very well. So this is a simple queue class. Next, we're going to be looking at the double-ended queue, also known as BEC.